Hello all, welcome to Paritranaya. In this class, we shall discuss about nuclear reactions, and within nuclear reactions, two different types. One is fission and the another one is fusion. So these reactions are very much important from general curiosity point of view as well as exam point of view. So when it comes to electricity production, so generally we have various sources. One is thermal power plant wherein we use coal. Similarly, we have hydro power plants and so on. So similarly, we have nuclear power plants. So in nuclear power plants, we use nuclear fuels to generate electricity. So along with the generation of electricity, it also produces some materials which can be used in the production of nuclear bombs as well. So in this context, so repeatedly do appear in the newspaper, and also it becomes important from the exam point of view. So let us try to understand the difference between fission and fusion reaction. So both fission and fusion reactions, they are energy releasing reactions. They release tremendous amount of energy, in which energy is released from high powered atomic bombs between the particles within the nucleus. So there are particles within the nucleus. So those particles, they will release energy. So how they will release energy and what is the difference, we shall just look into it. But what we understood is both fusion and fission, they are energy releasing reactions. Energy releasing reactions. So when it comes to nuclear fission, it is a splitting of an atom into two or more smaller ones. So one atom is there. So this atom will be split into two smaller atoms. So this is called as fission reaction. Okay, fission reaction. Now, in order to understand it properly, what we can do is we can take an entity, any box or something. So we'll break it into two. So when we are breaking it into two, obviously some noise is generated, some sound is generated. So that sound can be compared with energy. So it means whenever an atom splits into two, so an energy will be generated. So we can compare that noise with energy. So this is fission reaction. In case of fusion reaction, fusing of two or more smaller nuclei. So smaller nuclei or atoms, they'll come together and they'll form a larger atom. And this larger atom will have higher atomic number. So what is this higher atomic number? So it will have more protons in the nucleus. Okay, more protons in the nucleus. So what are protons, what are neutrons? So that detailed discussion we have already done in a separate class. So you can watch that video. But here we understood that in fusion reaction, two or more smaller nucleus, they'll come together and they'll form a larger atom with a higher atomic number. So here also it releases energy. So here we can compare it to what? Clapping of hands. Now when we clap hands, now here it is fusion. When we clap, now whatever the noise or sound that is produced, so that can be compared with an energy. So here we understood that both in case of fission as well as fusion, energy is produced. Energy is produced. But the fundamental difference between fission and fusion is here splitting of an atom occurs, here fusing of two or more atoms occur. Next, from the exam point of view, what kind of questions they can ask? So naturally, what kind of reactions do take place, whether fission or fusion? So naturally, fusion reaction occurs. So where does it occur? It occurs in stars such as sun. So whatever the energy we receive from the sun in the form of heat or light, so we are receiving it because of the fusion reaction that happens in sun. So in sun, there is no fission reaction. The fission reactions, they do not occur normally in nature. Then where do they occur? They occur in an artificial environment. For example, as I mentioned, in nuclear power plant, in majority of the nuclear power plants, the reactions which take place is fission reaction. Because the technology related to fusion reaction has not yet been completely developed, with the help of which we can generate electricity. So now majority of the nuclear power plants, they work on fission reaction. A very important point to note. Next. Now question can also be posed in this way. Which one produces more radioactive materials? So what are radioactive materials or particles? So at a superficial level, we shall understand that radioactive particles are the one which are harmful for human beings. So which one will produce more, fission or fusion? So fission produces more radioactive materials. Fusion produces very less and sometimes even no radioactive waste at all, if we are used right type of atoms. Okay. But to initiate a fission reaction, if we have used a fission kind of trigger, then it may produce what? A small amount of radioactive waste. Even that small amount of radioactive waste, it's a very short-lived. Okay, very short-lived. Unlike the radioactive material which has been produced by fission reaction, which lasts for a long time. So here it will last for a very short period of time. Again, a very important difference to note from exam point of view. Next, which one produces more energy, fission or fusion? So here we understand that fusion reaction, it produces more energy. It produces more energy than fission reaction. So fission produces less energy, fusion produces more energy. Now, when compared to normal chemical reaction, so which one produces more energy, fission or normal chemical reaction? So fission reaction, it produces millions times greater energy than the normal chemical reaction. So an example to consider is firing of a bullet. So when we fire through the firearm, so the bullet, how it fires, it gets fired because of the chemical reaction. Now the type of energy which has been produced there, so compared to that fission reaction, it produces energy which is million times more than that. And compared to fission reaction produces 3 to 4 times more energy than fission reaction. So if you place it in ascending order of the energy production, so lowest will be chemical reaction, next is fission reaction, and the highest will be fusion reaction. Now, most of the times we have read in the newspaper about 2 different types of bombs. One is atomic bomb or atom bomb, and the other one is hydrogen bomb. So what is the basic difference between them? So when it comes to atom bomb, it works on what? Fission reaction. When it comes to hydrogen bomb, it works on what? Fusion reaction. Okay, it works on fusion reaction. But in order to initiate this fusion reaction, in the initial stages, fission reaction is required. Okay, fission reaction is required, but majorly it works on fusion reaction. A very important point to note here. Next, in order to start the fission reaction, what is required? We require uranium, so 235 isotope, and high speed neutrons are required for fission reaction. And normally on Earth, an example of a fusion reaction is the fusion of deuterium and tritium. So what are these deuterium and tritium? They are isotopes of hydrogen. So what are isotopes? Already we have discussed in a separate class, so you can watch our video to have an understanding about the isotopes. Okay. So if at all in the examination, if they ask you, so the deuterium and tritium involving reaction, whether it is a fission reaction or fusion reaction, it's a fusion reaction. Important point to note. Now next, high density and very high temperature environment is required in case of fission reaction, unlike fission reaction. Next, this point is also very important. Now, in order to initiate this reaction, in order to initiate both fission reaction as well as fusion reaction, where more energy is required, whether initial energy required is more in case of fusion or fission. So little energy is required in fission. So extremely high energy is required in fusion. Why? Because 2 different atoms, so they are not willing to join. But at that time you want to bring them together. So in order to bring them closer, a lot of energy is required. So always there will be an electrostatic repulsion between 2 atoms or 2 nuclei. So that's why they will not be willing to join. But in order to forcefully join them, we require extremely high energy. That's why extremely high energy requirement is there in case of fusion reaction and not fission reaction. Next, fusion reactors cannot sustain a chain reaction, and so they can never melt down like a fission reactor. Very important. Now the chances of fission reactors failing are more, because in fission reactions continuously there will be chain of event, so finally the whole reactor might fail, it may melt down. But as there are no chances of chain reactions, there is no chance of meltdown. A very important advantage of fission reactions over fission reactions. Okay, very important. Next, so which one would be the ideal for generating energy? So the ideal process for generating energy would be fusion, but presently we do not have the technology competent enough to generate electricity using fusion reactions. Okay, that's why most of the nuclear power plants, they are reliant on fission reaction. It is essentially inexhaustible, low cost fuel. So when it comes to fusion, the fuel used here is of very low cost and also inexhaustible. So very easily it cannot be exhausted from our environment. So it exists, means a lot of fuel is available. Unlike fossil fuels, so it may be exhausted in the near future, but this fusion reaction required fuel, it will not exhaust soon. Now when it comes to energy generated through fusion reaction, so the high energy density of the fuel in fusion, so the type of fuel which we use in fission fusion, it has what? High energy density. So that's why it can produce a lot of energy, and transportation cost involved is very less. Very important. At a superficial level, if they ask you, so transportation cost is less in case of fission reaction or fusion reaction, then we should be able to identify that it is less in fusion reaction. Okay, again, an advantage of fusion reaction over fission reaction. Next, fusion reaction, it does not produce any greenhouse gas, soot or acid rain. So hence there is no possibility of runaway or meltdown, runaway reaction or meltdown. So again, an important point to note. So in the examination, if they ask you which among the following reactions does not produce any kind of greenhouse gases or acid rain, then it is fusion reaction. So what is acid rain? What are greenhouse gases? Already we have discussed about these topics in our environment related discussions. So you can watch those videos to revisit the things related to greenhouse gases and acid rain. Okay. So that's why when it comes to proliferation or harm, there is a less harm from fusion reaction. Less harm from fusion reaction. This is a very important point to note. So these were the important differences between fission and fusion reactions. So if at all we try to dig deeper into these aspects, we'll get much more information. But as an UPSC aspirant, as a civil services aspirant, we need to understand the demand of the examination. So we need to become jack of all the subjects. So also from that point of view, we also need to know where we have to stop. So this much information would be sufficient. On top of this, as part of the current affairs, whenever new material comes, so we'll make add-on to this and we shall try to revise it accordingly. And this much information would be sufficient from both prelims as well as mains point of view. So in this class, we discussed about the difference between the fission reaction and the fusion reaction. Similarly, in the forthcoming classes, we'll be discussing about the other important science and technology related topics from exam point of view. For all our further updates, subscribe to our channel and hit on the bell icon. Thank you.